All right, everyone, here we are doing a pretty intense looking example. And I know it could look a little bit scary, but I really think that you're going to be just fine. So just hold on to your butts and let's try this out. So you should have just watched the previous video and taken notes on exactly how a, b, h, and k impact the parent function y equals sine of x. Sometimes that x is replaced with a theta, sometimes the y is replaced with f of x. It's all the same. Now, one thing I want to point out before we continue is this is given to you in a very nice form. It's given to you where the 7 is nicely pulled out in front of a bonus parenthesis over here, and it makes it very easy for you to identify the h value. Another thing they could do, though, is they could distribute that 7 to this over here and present the equation to you that way. What would that look like? If that 7 were distributed before it was given to you, it could look like y equals, and also I'm going to spice it up a little. Sometimes they take that 6 and they'll put that in front just to spice it up. So that's a 6, and then that's minus 3 sine. And what do you think people want to do? Combine. Can they? No. They're not like terms. 3 is attached to the sign. 6 is just the 6. They are not like terms. Now I'm distributing. So that would become 7x plus, always think smarter, not harder. You reduce first. Division can come before multiplication in any example, really. Just make sure you do it correctly. So 7 over 28 reduces to a 1 over 4, and I'm left with 5 pi over 4. So what issues would people encounter if they were presented an example in this way? First and foremost, they might try to combine those. Do not combine. Okay? And they might think, let's say, not left 5 pi over 4. It's not, okay? Shame, shame. It is left 5 pi over 28. That's your h. So plus moves it to the left, right? We talked about the bonker house. And this over here is a little misleading. So if you presented the equation like this, you have two options. Option 1, you can factor out the 7. How do I factor a 7 out of that, though, right? A little confusing. If you have to factor out a 7, technically what that means, this is good knowledge, advice, okay? You multiply out front by 7, and you're technically dividing inside by 7. I don't want to start combining a fraction divided by something, so instead I'm going to multiply outside by 7 to factor out the 7, the greatest common factor in a way, or a common factor. And I'm going to multiply, instead of dividing the inside by 7, I'm going to multiply everything inside by 1/7. So in your head, you're doing 1/7 of 7x plus 1/7 of 5 pi over 4. What does that leave you with? 7 is still out front. 1/7 of 7 is 1, so it's just x plus, still a plus, 7 times 4, we're going to multiply and we get 28. 5 pi over 28, and then we get it to look like that. And the other option is, so that's option 1. Option 2, let's just go down here, is you can take the entire inside of the parenthesis, so take 7x plus 5 pi over 4, and you set it equal to 0. But you want to be careful because people make weird algebraic mistakes. Then we get 7x equals negative 5 pi over 4. And don't divide by 7 again, all right? Multiply by 1/7. We're big boys and girls now, right? So x equals, so we're going to multiply 1/7 here. Adios. 1 over 7 there. Am I off the page a little? And I will still get a negative 5 pi over 28. So here I get a negative 5 pi over 28. That already tells me left 5 pi over 28 because it's giving me the first tick mark. It's giving me where I start. So it's up to you. Personally, because we've been graphing so much and always thinking of it in this form like this on every other function throughout Algebra 2 and now in pre-calc, that I kind of prefer option 1, but it's up to you. Choose your own adventure. All right. Now, thinking of all the things that we have to implement from the previous video, we're going to graph this. If you're feeling ambitious and you want to press pause and just kind of go for it and see what you come up with, judgment-free zone. No one needs to know. No one needs to see if you make a mess on your paper. That's why we make whiteout or erasers or the back of a paper. Just flip it over and just do it over, okay? So I would definitely recommend that you try it by yourself. Don't underestimate what you can get. But if not, you could join me right now. We're going to work on this. The first thing I'm going to do is I'm going to look at the fact that I have a negative in front. I know that when sine is positive, I've memorized the shape of it. And if you forget, just revert back to that unit circle process that we talked about. Since it's negative, I know that my graph will have this shape instead. So what am I doing? How am I drawing this already? Well, I'm just drawing the shape. And what I'll do is I'll just label my values on the picture according to the shape and the equation. So here it's going to be concave up first, concave up, looks like a cup, concave down second, concave down, looks like a frown. Put a little tail at the end, curving bit, put a little tail at the end. Okay, now the next thing I might include, so I took care of the negative, and I guess I could just color code what I'm doing a little bit, like kind of checking it off. I'll grab the blue. So I took care of the negative already, okay? And I took care of the fact that it's sine. Done and done. The next thing I'm going to take care of is the 6, just because it's kind of easy. So I had done that in pink on the last page, but I'm just going to go right here. I'm going to draw a dashed line right through the middle. Now, I'm not drawing my x or y axes yet, okay? You'll see why. This is going to be at y equals 6. I'm just writing the equation of my sinusoidal axis. You could label that if you want. Want to put midline? You can put midline. Or sinusoidal axis. Put the sinusoidal axis. Okay, all good. There we go. So the 6 is taken care of. Next thing I'm going to do is, I suppose the next thing we could do is take care of the H, or my first tick mark. So if I wanted to know my first tick mark, now this is 6, so I know that my x-axis, or actually, no, let's not do that. Let's look at the 3. I know, I'm jumping all over, sorry. It's like one thing when you do it yourself in your head. It's another thing when you're doing it out loud and making sure someone else could do it too, you know? 3. I'm only looking at the positive because absolute value, remember? If that's 6, 3 is how far it is to get to that and how far it is to get to that from the 6. That I had used the purple highlighter for on the previous page. So how high up are we moving? Well, we're going up 3 units, and here I'm going to go down 3 units. So what else does that tell me? Gives me a lot of clues here. That means this is going to be at 3, okay? So maybe a little note for myself. I'm going to say, okay, that's 3. And this, 3 higher than 6, this is going to be up 9. Again, I'm not putting in my axes just yet. I will in a few minutes. But if that's 3, 6, and 9, well then 3 further down, that's my x-axis because that's 0. So now I have somewhere to put my x-axis, so I can place that. And I always talk about this, but I've been that person too many times that gets ahead of myself, and I draw my x and y axes before I plan out my entire graph. And then I'm like, ugh, I don't have enough room. I don't have enough space to fit this or fit that. Well, then my solution was just draw my graph and draw my axes around my graph. Now I could put my 5 tick marks underneath the 5 important spots. And we're making some progress. Now I can take care of the H. X plus 5 pi over 28 plus, crazy house, means left. We went left. So this is negative 5 pi over 28. That's how we label the first tick mark. Now I'll put my y-axis in once I know, because now that I'm negative, once I know I either have all negatives or somewhere I'm going to change from negative to positive as I move from left to right, that helps me figure out where my y-axis will go. So last thing we need to take care of is the 7, and that's B, and that affects your horizontal stretch or compression. Normally, the whole length from start to finish is 2 pi. Normally, this is a quarter of 2 pi, which is really 1 pi over 2 or 2 pi over 4, 1/4 of 2 pi. Check back your notes. So I want a quarter of this graph though, which is affected by that 7. The period formula is 2 pi over B. B equals 7. That's the length of the period. But I'm not going to add that and try to find midpoints. Like, I don't have all day for this. So I'm going to find next letter of the alphabet, LMNOP, Q is 1/4 of means multiply, the period. And what's the period? 2 pi over 7. Oh, this is convenient. I get 2 pi over 28. Now, why is that convenient? Because I already have a common denominator, and it makes adding Q onto the H value a lot easier. If you don't have a common denominator, you'll find one and add that. So I'm going to keep adding 2 to my numerator until I get to my last tick mark. So if I add 2, I get negative 3 pi over 28. Add 2 more, that's negative 1 pi over 28. Add 2 more, that's positive pi over 28. And I add 2 more, and that's positive 3 pi over 28. So where would I draw my y-axis? Well, it would actually be exactly in the middle of these 2 points right over here. So ever so carefully, draw myself a y-axis. Extend that through. Now I could kind of label my axes. So here's my x and my y. And then my tick mark here, that's 6. Careful. And right here is 9. And here next to this guy is 3. Do you need to put tick marks for 1, 2, 4, 5, whatever? No. Okay. Don't clutter this up. We care about 5 main tick marks on the x-axis. We care about 3 main tick marks on the y-axis. Sometimes when something goes through the origin, you might only see 4 tick marks or 2 tick marks, but that's all we really care about right now. And that is how we graph a fully transformed sine function. We took care of everything. All right. So any other color coordinating I should do? I suppose the B value I had done in yellow, and that affected these. So remember, these were affected by the yellow and the orange, which was the quarter. So the quarter period, that size, the quarter period, which was 2 pi over 28, that's how big it is here, 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 and there. The period, which is actually 2 pi over 7, or if you think about it, 2, 4, 6, 8, 8 pi over 28, which is still 2 pi over 7. The period, did I color that in, I think, yellow? Yeah, I'm kind of messing up my color coding, so forgive me. But that period length is how long it is from really start, to finish. So from right there, right here, okay, all the way to here, okay? And the quarter period is each individual. Boom, 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 4 quarters make a whole. Anything else that you could think of? I think that's more or less all of it. Here's where I was explaining K, which is 6, plus 3 and minus 3 are what give you the 3 and the 9. And my starting tick mark, I think I did in that poor green dried up highlighter. And that was this right over here. So I hope that you found this helpful. I hope that you think you have a bit of an understanding. So I would like you to try an example on your own. The example I would like you to try is as follows. Y equals -2 sine 3 times, could go like this, x minus 2 pi over 9 plus 5. Sorry, I just have a list of examples. This one is actually kind of a little easier in a sense because your graph is going to move to the right And it makes drawing in your y-axis a lot easier because we don't have to worry about having any negative tick marks. If you don't understand what I mean, hopefully you figure it out later, but good luck on this example. I hope you felt good about the last one, and I'll see you in the next video. Thumbs up if you got it, thumbs down if you are having a meltdown, okay? Have a great day.